much, sir. Okay, thank you very much.
Any other questions? No. All right, so we'll start at 10:15, right? When the other person's coming. I'm recording. All right, so in class, Mr. taught you guys about triangle of forces, right? So when we have forces in equilibrium, like just a bunch of forces acting on a point, if they're in equilibrium, they usually form a closed polygon. And for three forces, that polygon is a triangle. Right? So they would form a triangle. And you'd find that the direction usually goes circular. So let's just try and match this to this. So let's say we have three forces acting on a point, right? And we were to essentially move that, create a triangle with them. I want to say create a triangle with them. What I mean is just line them up in a way that makes a triangle, right? That would look like just something like this. So we take this force here, right? And we shift it downwards. Put it here. Then we take this one here, we shift it back here, put it here. Can you guys see that? And we create a triangle. So that would look something like this. As I said, three forces in equilibrium, the directions are usually like this. So it's like head to tail, right? Just going around clockwise or anti-clockwise. But if these things weren't in equilibrium, what you would find is that the polygon wouldn't be closed. So let's say we had two forces. Two forces, 1, 2, and we had another force here that was supposed to make the system into equilibrium. So these two forces here, right? 1, 2. Right. The resultant of these two forces, if we first take this force, like this one here, right? And we kind of try and move it back this way so that they line up, right? Head to tail, head to tail. So that's what we'll do here. Move that one there, right? Find the resultant. So you guys remember the resultant from CFEC? The resultant force is just the sum of these two. So if we move like 4 across here and then 4 up, that's the same as just moving the resultant, right? And the resultant is generally in this direction. So what you find is that there's a disconnect. It's not as smooth going around from here to here to here, because this is in the opposite direction. So if we were to take this force, right, instead of some force here, that would be the resultant. This is the resultant. We want a force that would go the opposite way, but the same magnitude, to cancel out these two forces, right? So whatever these two forces are, we want someone that the opposite of the resultant, going this way, to cancel out this force, some of these two forces, and maintain the system in equilibrium. Right? So to maintain the system in equilibrium, we need a force of the same magnitude of the resultant, but in the opposite direction. We end up with this nice smooth thing. Okay? Now, if this was too short, right? If it was shorter force and it wasn't enough to overcome this upward pulling and this sideways pulling here, right? Then this triangle wouldn't be closed, right? Triangle would have an opening. So the polygon wouldn't close. And that's where the triangular forces theorem comes from. Three forces in equilibrium can make a triangle, or three forces that make a triangle are in equilibrium, right? So that's just the triangular forces theorem, simply put. Now let's move on to question 1. Three forces, A, B, and C, act in the same vertical plane from a point O. Force A is 30 Newton and acts horizontally to the left of O. Force B is 40 Newtons and acts vertically upwards. Determine with the aid of a force diagram the value of the force C and the direction in which it acts if the forces are in equilibrium. So if the forces are in equilibrium, we can make a triangle, okay? And first we gotta start off with a force diagram, right? So we take our two forces, 30 Newtons and 40 Newtons. This here is A. Force A acts horizontally to the left of O, force A. And force B, 40 Newtons, acts vertically upward. So this is your point O, and you have these two forces. So what we do is we slide this one across here, right? So we take this, slide across there, and then we slide this one up, right? And we slide this one across. And we join them up and make this triangle. Does everyone understand how we create this triangle from these three forces?
Go over that again, please, sir.
Go over the triangle.
Yes, sir. No, sir, not from there, from the explanation just now.
Yeah, well, so there's one force, right? Up, 40 Newtons, right? There's another force to the side, right? 30 Newtons. Right? That's here, right? These two, 1, 2. Let's forget about this one for now. What we're doing with this 30 Newton force is we're just taking it, right? Taking it, and what we're doing is essentially just moving it and putting it here, right? Easy. So we're doing that with the 30 Newton's force. And then, remember as I said, these two the resultant. So to balance it off, we need a force coming this way. That's the same magnitude of the resultant, right? And we take this force, so this one here, we slide it across there. With this thing here, okay? Same direction, same magnitude, 30. And then this one, take it and we slide it, right? Creating the triangle. You see the triangle there? So that's essentially how we get this. So we take these same vectors, right? That are in this diagram, and we just move them around. Slide this one up, slide this one across, and we create a triangle. Now, after creating the triangle, we know some of the magnitude, right? So remember B is 40 newtons, so we put that in. A is 30 newtons, so we put that in, right? This here, this force C is, of course, your unknown. Right? So we don't know, so we're going to find that using our Pythagoras Theorem or whatnot. So we know here, right, if we slide this across, we know that this would create a 90 degrees here. So this here is just 90, right? Okay, you get. Now, we slide this up, it's going to go there, right? So it's like, okay, so you see this angle here, theta, this is the angle we want to find. So what this angle is going to tell us is which direction C is going, right? So we want the value of 4C and the direction which it acts. So with the angle, we can say, okay, it acts 30 degrees from the horizontal, 40 degrees from the horizontal. We can give them, we can answer the question, right? We can give them a direction. So we also need to find the angle. Now, when we slide this up, right, we know from Z angle, there's two parallel lines, right? And in this case, they cut like this, right? So we know this angle here is the same as this angle here, right? So if we imagine sliding this up, this here, to here, which is what we have here in this triangle, we know this angle and this angle. So we can say theta, this angle here, is the same as this one. So everything we need, we can just calculate from this triangle. Yeah? So let's start calculating our forces. So we create a triangle, and that's the hard part there. All we need to do now is find the values. So everyone remembers the Pythagoras Theorem, right? The square of the hypotenuse, right? The square of the hypotenuse, this here, A, and let's call it B, C. Square of the hypotenuse is equal to the sum of the square of the other two sides. So we square the other two sides, right? And we take the sum of them. And that's Pythagoras' theorem. And of course, we take this square over and we have a square root here, right? Nothing too fancy. Something I should have already. So in this triangle, the lengths are the forces because we use force to essentially scale the diagram. We say 1 Newton is 1 unit. If you were to draw this to scale, we would say something like 1 Newton is equal to 1 centimeter. And so this here would be 30 centimeters long. And we draw it to scale, and we could use a protractor, get a 90-degree angle, draw this up to scale, and then just measure this off, right, with a ruler or something. And we could get the answer. But we don't want to do that. We want to calculate it. So we just create a triangle. We say here 30 units long, here 40 units long. And we want to find what length this line would be. So we just use Pythagoras theorem. We say FC is equal to the square of FA. FA is 30, right? Plus the square of FB. And you take the square root of all of that, right? So FA is 30, as we know. FB is 40. Do a little bit of math. Just plug this in, take calculator, and you will end up with 50 newtons. Does everyone get that?
Yes,
Yep.
sir.
Yeah.
Yes, sir.
Okay, good. So very easy, right? So now, another thing you guys would remember from high school are the trig ratios, right? So let's just go over them quickly. So some old forces can always hear their owners, or some people just say soka toa, right? So what this little thing here means, that's just giving us the trig ratios for right angle triangles. So along with Pythagoras theorems, when we're dealing with right angle triangles, we also have these trig ratios. And that what that means is sine theta equal to the side opposite that theta, right? The opposite divided by the hypotenuse,
side to the
right?
long side.
Divided by the hypotenuse. Okay. And then cosine of theta, the adjacent, which is this side here, the angle is here, the side adjacent to the angle, or the hypotenuse, and tan is the opposite over the adjacent, right? So however you want to remember that. Okay. So now we found the magnitude 50. Now we want to find the angle, yeah? And that angle is theta. So we want to take one of our trig ratios. And we want to look at what values we have. Well, we have all three, right? Because we just find 50. Let's use the ones that were given to us. So this here is the opposite and this here is the adjacent. So we can use tan, right? So that is tan of theta is equal to the opposite over the adjacent, right? So again, tan of theta is equal to, and we come up to our diagram, the opposite is 40, the adjacent is 30. That's equal to 40 newtons, right? Over 30. Therefore, theta, and now we're going to do the inverse operation of tan, or what you guys would know as carry the tan over, and we take the tan inverse of 40 over 30. And we should get this answer. Simple enough? Any questions?
No, sir.
All right, I see Sidesh raise his hand. How do we show that force is downwards and to the right? Do we just explicitly say such, or is there a math? Yeah, so the question also asks for direction, as Sidesh is saying. So let me just explain that again, right? So when you start conceptualizing this diagram, right, we were giving two things. A 40 newtons force upwards, vertically upwards, and a 30 newtons force horizontally, right? O. So let's say to the left of O. Horizontally to the left of O. So two forces like this. One is pulling up this way, one is pulling that this way. So visually in your head, to balance that off, to put the system into equilibrium, we'd want a force pulling back this way, wouldn't we? So that's how we can get the general idea of which direction to draw this. And mathematically, we can prove that by saying that the resultant of these two, yep, the resultant is this way. So we want a force that's equal in magnitude to the resultant of these two in the opposite direction. So that's how we end up with this general direction to draw the force E. Right? So magnitude and direction. So it should be the magnitude of the resultant of these two, which is essentially what this line is, and how we created this triangle. And then we find the magnitude using Pythagoras' theorem, which is 50 newtons. So a vector is both magnitude, right, and direction. Yep. So magnitude and the direction is 53.1301 degrees to, probably write this in, to the horizontal, right? To the horizontal. And then you just write out. So you remember we already established that this theta is this theta and this theta is this theta, right? So by finding this theta, we know that in this diagram, this is it. So we're saying it's 53 point something degrees to the horizontal. So take the horizontal, this line here, and just 53 degrees from that, and that's where this is, right? And of course, we measure angles like this, right? So you remember you guys taking bearings and whatnot in high school. So it's very clear that saying 53 degrees to the horizontal means this and not something like this, right? So does that answer your question, or is it something else that you're trying to ask?
Excuse me, sir. I got a question.
Yeah.
You could use Lamy's theorem or something to find the angles though on this same question after you find the force.
Lamy's theorem. So Lamy's theorem would be. Let me just mute your mic. So Lamy's theorem would be something like we'd need this angle, right? And we'd have these magnitudes. We found this here as 50, right? So you can. So Lamy's theorem would be something like 50 over sine 90 is equal to, and you'd want this one, right? And this angle here. So the angle that you would find here, let's call this something, is equal to 30 over sine of whatever that thing is. So you can find this angle and you can say how much ever degrees you find to the vertical, right? To the vertical. So you can use Lamy's theorem, but I mean, trig ratios are so much easier than just moving this, because here you'd have to calculate this and then carry it over. And then you probably just want to flip this entire thing first.
I just asked, sir. I just asked.
Yeah. Well, we can just do it really quick. All right. So this here would just be sine 90 over 50, right? 90 over 50. Right, and that there is equal to sine of this thing over 30, right? So just multiply this here by 30, right? And then we take the sine inverse of this entire thing, and we should get an angle that's this plus 90, right? So that should be 143.13, right? That's what this should give us. So you can work it out real quick, punch it into calculator, and you should get something like this. All right. Any other questions? No. All right. So yeah, you work this out, and you should get 143, right? Let's see, one more question. Okay, good. So next, number 2. Now, right off the bat, we see 80 degrees, 150 degrees. So we know it's not a right angle triangle. So we know that with triangles that aren't right angle, we can't use Pythagoras' theorem, right? So with right angle triangles, we have Pythagoras theorem and we have the trig ratio, sine over opposite, hypotenuse, and whatnot, right? But for triangles that aren't right angle, right?
Question, sir, before we move
We
on.
have,
So if they give you the angle 90, so you don't know those are right angle triangle instead
yeah,
of 80.
yeah, you
Okay.
don't know it's right angle. Or sometimes they might then explicitly tell you, right? What they might say is one is horizontal and one is vertical. Maybe like this way, horizontal to the left. Or one is vertically downwards and horizontal to the right. So you know that in your head should just be, oh, that's forming a right angle triangle, right? So sometimes they might not explicitly tell you. Good. So when triangles aren't right angle, we're totally confused. So we can't use Pythagoras, we can't use a regular sine, cosine, and tan ratios, right? So we start to use two different things, and those are the sine rule, or sometimes called the law of sine. So sine rule and cosine rule, or the law of cosines, right? So those are two things that we can use to find the angles and the lengths of the sides for triangles that aren't right angles, right? So these two. Additionally, there's Lamy's theorem, which is an extension of the sine rule applied to these space diagrams that you'll see, right? So let's go over number 2, and we'll find that these two will pop up, right? So 3 chords, A, B, and C, are attached to one another at a point O. This point O. The angle between chords A and B, so 3 chords A, B, and C are attached at some point O. The angle between chords A and B is 80 degrees, right? 80 degrees. And that between B and C is 150 degrees. So B, C, 150 degrees, right? This we don't know. If the force exerted by chord A is 100 newtons, right? So chord A, this force, 100 newtons. Well, we're not determining graphically. Determine the values of the forces exerted by chords B and C, assuming the 3 forces be in equilibrium. So equilibrium, 3 forces in equilibrium can form a triangle. All right, so we already know how to start working this question, right? Just start forming a triangle. Good. So here we have 100 newtons for A, right? Let's just keep that in the back of our head. Good. So we're given this angle, and we're given this angle, right? So now to calculate this other angle, what we do, because we know that these angles go around in a complete circle, and there isn't anything like here, you know, with some missing part, right? A missing part to say that, oh, it's not a full circle. And we know the amount of degrees in a circle is 360. So we just do 360 minus 80 and minus 150, or we just add up 80 plus 150 and subtract that from 360. Get 130, right? So we can find that this angle here is 130. Pretty simple. Now, let's just say one like this. So now, this here is some angle, let's call this. Now, we're moving this around now, we're trying to form a triangle, right? So if we were to slide this to somewhere like here, slide it here, we create this angle here, right? And we'd want to find what that value is, right? But one thing we need to notice is that this here, sliding it, we're maintaining its direction, general direction, and it's kind of creating a line. So we can come to the conclusion that this here, right, here, is 180 degrees. So therefore, this angle here should be 180 minus theta, right? And that's equal to this angle here. So as we slide these angles around, it's good to keep this in mind. Understand how this works, right? If you want to find that angle. Go back to the main question. So we created a diagram. We have directions. We know all of them already, right? So let's create a triangle. Now, as we go on, when we see something like this, we'll know that creating a triangle isn't necessary because we have Lamy's theorem, right? But for now, let's create a triangle and work it out with a sine rule, work it out with things you know. So let's slide this across. This here is 80, right? And remember it's 80, right? So it's not 90. So as we slide it, so one here, right? And this one here, less than 90, right? So as we slide here, this side is going to be bigger, right? If it was 90, it would just slide across here. But this here is less than 90, right? This here should be slightly bigger because this is 80. So when we slide across, right, here, this angle here, yeah, we'd slide across here, should be 180 minus 80, give you 100, right? Now, let's slide this one down here. Trying to create this angle here, right? So this here is 130. 180, sorry, minus 130, right, which is equal to 50, right? Just give us this one here. And same way for this one, we slide up this way, right? Trying to create this angle here, right?
Excuse sir.
Yeah.
For that angle that you just find, you couldn't have done the 150 minus 90 also.
Yeah, you could. Yeah. So yeah, 150 minus 90 would just give you this, right? Wait, 150 minus 90?
Yes, sir. That's what I was wondering.
Here, like this line here. Well, oh, this one here, right? So this one here is good. 150 minus 90 is 60.
Yeah, would get 60 from this side and the other side you get 50.
Oh, yeah, because like I know this here, right? Seems.
Oh, yeah.
Yeah, but this right? This isn't exactly a vertical line, and this isn't exactly a horizontal line, right? This is just with reference to A, B, and C, right? So,
Yes, sir.
so remember this here, right? The horizontal line would be here, but if you slide this one across, right? Because remember, it's slightly up. This is 80, right? It's not 90. It
Yes,
would come here,
10
and
degrees
you'd have the 10 degrees here, right? So it wouldn't work out like that. Good.
All right, thanks, sir.
So as I was saying.
Question, sir.
Yeah.
Question, sir. Why couldn't you put BO opposite?
But
A and B
what?
could work. B. You see how you got B on the left hand side, right?
Yeah.
Why couldn't it go on the right hand side and then C go to the opposite?
It just depends on how you want to create your diagram, right?
Okay. Did I just ask?
Yeah, so it just depends on how you want to create your diagram. Right? So if you put A and you know between chords A and B, 80 degrees, right? So if you want to put your B here and you put your 80 degrees here, that's fine, you know. But remember to keep track of your values and don't confuse yourself, right? Yeah. So whichever way is easiest for you, as you see it and you think about it, how you read this question, maybe you're a left-handed person and drawing B this way might be more comfortable for you. But it's important that as you go about methods that vary from this, you keep your head on and you make sure you don't make mistakes, right? Because little things add up. And instead of getting 10 out of 10 on tests, you get like 5 or 6, right? Okay, so because when you do this, and then you make a little mistake, and then you come over in the triangle, and then you think something is 90, right? Like there, and you end up with 60 degrees here as the angle, right? I can't do anything about that. All I can do is subtract 1 from your paper, right? Okay. But yeah, you can, and just keep your head on when you're varying from this. So work the questions on your own and just use this as a general guide on how you would go about the solution, right? It's not the end all of anything. It's not like a Bible. It's just how I would work the questions, right? And Miss, of course, would have her own way of working the question. But as you can see, no matter which slight variation you work, you'll always end up with the same answer, unless you made some mistake or broke some kind of physical law or some mathematical law while doing the question, right? So even if your method might vary a little bit, as long as you don't break any rules, you should get the same answer, right? Okay, so this angle here, sliding up here. So this angle here, 180 minus 150. And this here should give us 30. So we found all three angles and we were given the length of one side, so we can use sine rule. So let me just go over the sine rule.
Excuse me, sir.
You're asking a question?
Yes, sir. Could you please complete the triangle on the diagram before that you got?
This force diagram.
Yeah, complete the triangle right there for me, please.
So what we do, this slide across here, right? Yeah.
Uh-huh.
Yeah, slides across there. Yeah. Okay, that slides across there.
Thanks.
Let's go. And this here goes up. Yeah. And remember, this is not 90, right? So this is 80. So that's why this would be 100, if you think about it. And the angles just kind of fall in. Yeah. So this triangle here not look similar to this one? You can see. And from that, it's just about figuring out the angles, right? Yep.
So, thanks.
Yeah. So if we kind of just extend this line here, we can see that this angle here, right? It's as the same as this one. And we do some other things and we can find these angles too, right? So that's how we create a triangle. We just move these around. This there, slide up, and we fix them together. And as long as the system is in equilibrium, they will join up and form a triangle. No problem. Okay. So we know the angles of this triangle, and we were giving the force exerted by chord A, and we have to determine B and C. So essentially what they want is the magnitude of these two lines, right? This one, and this one. And how do we go about finding that? Well, that's just sine rule. So let's talk about the sine rule. So let's just drop a triangle. So for triangles that aren't right angle, we can't use Pythagoras' theorem, right? We can only use the sine rule. So let's say we had some angle theta and some side E and some angle alpha, some side C. What the sine rule tells us, is that if we take the magnitude of say side B and the angle that creates that side, the ratio of that is equal to a side C divided by sine of the angle which creates the other side, like this, right? So we take this angle and we look at what side it creates, or the side opposite the angle, right? And we create the little ratio of it. So we just put B over sine theta. And we do the same with the other sides. And this other side, let's call it A. A over sine some other angle. Right? So the angle and the side opposite it, and we can create these ratios. So if we had a missing angle or a missing side, we can find it just by using this rule. So let's say we wanted to find C, and B was, say, 10. This angle here was 60, and the angle opposite C was 30. We can create some sort of equation using the sine rule to solve this problem, right? So we look, B is 10, and the angle opposite it, right? Or the angle that creates the side that's 10, 60. So that's 10 over sine 60, right? Opposite here. Sine 60, and that's equal to C over sine, and the opposite angle C, right? 30. Sine 30. And then we could carry over this and make this sine 30 times 10 over sine 60 is equal to C, right? And we can find the value for C, even though this is not a right angle triangle. Now, you might see this in different ways. So another general way that you might see this popping up is just having these things labeled as capital A, B, C, right? And these sides, small a, small b, small c, and then this would just give you the sine rule as A over sine of big A. And this, what this just represents, that just means the angle here, right? And that's equal to little b over sine B, the angle, right? So you can see it in all sorts of different forms, but that's just generally what the rule states, and allows you to find sines and stuff with angles that aren't 90. Okay, good. So using the sine rule and this triangle that we created, we can easily find, say, this force C or this force B, right? So let's start. The angle is 30, the magnitude is 100, so 100 over sine of 30 as equal to, right, 100 over sine of 30, and say we want to find C, so C over sine of this angle here, 100 of 100, right? Sine of 100. And then so C is equal to sine of 100 times 100. This here is 100 newtons. This here is 100 degrees, right? With sine 30. So does anyone want to calculate this really quick? Take out your calculator, punch it in, tell me what number you get.
196.9 newtons.
196.9 newtons. Now, good. And as you'll see later when we work with Lamy's theorem, you'll get the same answer. Okay. And now let's do it for B. So B, this here is the same part. We're using the same side, right? Good. So B, which is B, right? We can just replace this here with B, right? And we place this angle 50, so no longer 100. This angle here. Now 50. And you do back these same lines.
Sir.
Yeah.
You're supposed to cross multiply?
Yeah, well, that's essentially what I'm doing. All right, let me cross, because what we're doing is, well, we're skipping a step, you know, for the sake of speed. But all right, let me break it down. Cross multiplying. So, okay. What I did was I took the denominator, right, the sine 50, and I just moved it over, right, and multiply by sine 50. But if you want to cross multiply, you can. So cross multiply, right? That is 100 newtons times sine 50, right, which is equal to B times sine 30, right? And then you'll have to take this over back now, right? So take this over and divide by sine 30. And as you continue working math and you move beyond regular C-sec math, you start noticing that this is the same thing as what we had before. So if you plug this in for your calculator, right, you should get 152 because we're finding B now, right? So someone plug it in and see what number you get. Anyone? Oh, when you guys get a chance, you're gonna find that it's 153. Yeah.
153.2.
All right, good. So, and that's the same. Well, that's the answer in the book, right? So, sine rule works, and if you know things like cross multiplying and stuff gives you trouble, things like solving the equation for B gives you trouble, then you know practice a lot. And if you find the sine rule difficult, you can find a video on YouTube. Just type in sine rule, and they can go over some examples for you. Really help you understanding, get you up to speed, right? Okay, so let's learn something new. So the sine rule works. You guys can do it. Okay. So let's just use Lamy's theorem, and you'll find that Lamy's theorem is simple. So this angle here, 100, right? And this 80 here. So this angle here is 80. So let's just call this that symbol. And this angle here is 180 minus 80, which is 100, right? But let's use this symbol, right? What I would propose to you guys is sine of this is equal to sine of alpha. So to test this out, take out your calculators and do sine of this here, which is 100, right? Sine of 100, and then do sine of 80, and tell me what answers you guys get. Okay.
The same thing.
Yeah, okay, good. Now do sine of 130 and sine of 50.
Hello? Hello?
Same thing.
Yeah.
And you can also do sine of 150 and sine of 30. So let's do the sine of 150 and sine of 31 on the screen so everyone could see. So 150, sine of that, 0.5, right? Clear. 30, sine of that, 0.5. So these angles here, if they're the same, when you sine them as the angles here, then we can just, instead of creating the sine rules, we can just say, okay, let's just put the magnitudes over these same angles, and we don't need to create a triangle and do the sine rule anymore, right? And that's how Lamy's theorem came about. Now,
Sir, can you please go back over that over? That same last line you just said.
oh, okay, good. So if we know that this, right, we just checked it. We did 150 and we did sine of 30, and both of them equal to half, right? 30, 150. So this here, right, when we're doing the sine rule, right, it would be this magnitude here, this 100 newtons, right, over sine of 30. Right? So where's the 100 newtons here, right? 100 newtons. And where's the other angle? 150, right? Here. So sine of 30, this 100 newtons over here. Now we move here, right? So if we can replace this sine of 30 with sine of 150, because we know sine of 150 is also 0.5, right? Then the theorem would hold true, right? So this, instead of writing 30, we can just write 150. Yeah, could we not? And have the same outcome. So instead of creating a triangle, what some guy named Lamy did was he noticed this and he was like, okay, let me just create some theorem called Lamy's theorem. And he just said, for space diagram like this, triangular force diagrams like this, if we take the magnitude of something and we divide that by sine of the angle opposite it, like 150, well, that's equal to the magnitude of another side, of another force in the true force diagram, divided by sine of the angle opposite it, right? So B here. So we find things like FB over sine 130, B opposite 130, A opposite 150, right? C opposite 80. So Lamy's theorem is just an extension of the sine rule. Any questions on that?
So, sir, for any triangle that are not right angle triangle, you can use either sine rule or Lamy's theorem to find the answer.
Yeah.
Okay.
And also, as you see, we'll use cosine rule sometimes because cosine could be a bit more convenient sometimes, right? Or we'll get to that in a few.
And when the triangle is a right angle triangle, you use only trig ratio and Pythagoras theorem.
Yeah, well, you could. Yeah, but you could also use sine rule, because sine rule and cosine rule and Lamy's theorem would apply to all of these systems, right? It's just
Okay,
that the right angle is easier because Pythagoras theorem is easier, right? And
okay.
this here, sine of some 30 over some 100 newtons over something, like that's easier to solve than sine on both sides, right? Yeah.
Yes, sir.
Good. So it's just that
Perfect.
for right angles, triangles, we have easier rules. So why use something more complicated? Yeah, when we have easier things like Pythagoras theorem and your regular trig ratios. Okay.
Sir.
Good. So we use Lamy's theorem and we generate these equations. And we want to find for B, so we use this part. We do the cross multiplication stuff. Give me a second, guys. Let me just get my charger.
What happened to the take?
All right, so yeah. So we use Lamy's theorem. We develop these equations. Yep. And now we can find B and C using this. So this here is f of B was sine 130. So we create this equation here. And then we simply solve for B. Right? Sine of 30, 130 is this. And 150 is 0.5. So we simplify the equation. Carry over, solve for FB. And we find the answers we got before. Yeah, so one of them, remember, was 153.2 newtons. And one of them was 196.69, 0.6 newtons, 67 newtons. Okay. So whether or not we use the sine rule or we use Lamy's theorem, which is just simple, we look here, opposite, opposite, create these equations quickly, carry over or do your cross multiplication stuff. Right, simplify this equation, and we get the answer, right? So sometimes there's no need to even do the triangle. Okay. Is this understood? Is this simply enough to solve these equations? Just like the sine rule?
Here, sir.
All right, so let's move on. And of course, I'll send this to you guys and we'll work along, right? So number 3, I'll leave as an exercise to you guys. So it's not hard. Just remember ship being towed horizontally, and there are 2 things pulling on it, right? And the angles here are 30 degrees and 60, right? So this is the same kind of diagram we've been working with. So number 3, you guys, I want you guys work it on your own and solve for these values, right? This, okay, good. So let me move on. So you guys work on this on your own and should get the answers. I think the answers are 30, 52. Yeah, so work this question using the methods you just learned. Let's move on to number 4. Yeah. So a vertical load of 100 newtons is supported by 2 chains, A and B, in the same vertical plane. The force A is 50 newtons and acts in a line 30 degrees to the horizontal plane. So the horizontal plane, 30 degrees from that is where this force A acts. Okay? So keep that in mind. Or 120 degrees to the 100 Newton load, right? determine the force in the chain B. So we have some load, some 100 Newton load, some bag or something hanging on some string attached to some chain, and one of the chain pulling 50 Newtons at 30 degrees to the horizontal, right? 30 degrees to the horizontal, or 120 degrees to the 100 Newton load, right? So the vertical load, 100 and 100 Newtons, right? So, and this horizontal here, so let's pretend this is 90. So here, 30 plus 90, that's equal to 120, yeah? But they told us that, so no need to find it. So let's look at this diagram and see what we want to use. So we know about Sine Rule, we know about Lamy's theorem. Let's try solving. Okay. Okay. So 100 Newtons and this angle here, we don't know. We don't know this angle here, right? All we know is this, and we essentially just create 180 and we subtract 120 and we find this, right? But we don't know this full angle here, right? So we write it as theta. So we write it as theta, some unknown, right? Good. And then there's a 50 Newtons force, right? And we again, we don't know this angle here. So it's another unknown, yeah? It's another unknown. Now, the angle we do know is this 120 degrees one, and the one opposite that one, right? Here is an unknown because we don't know what the magnitude of this force is. Yeah, we don't know what this force is. So let's just call that force B, right? So that's some unknown. What we find with these equations is that you can't solve them. You can do force B, right, over sine 120 is equal to 100 Newtons over sine theta. So with sine of theta would be, so we're not going to be able to solve for B or for theta. So clearly there's more work to do. Lamy's theorem can work. And additionally, what we find, if we try creating a triangle, so we create a triangle, we slide up the 180, right? 120 minus 180 gives us a 60 when we slide up, right? And we slide across and slide and join up the angles. But again, as we slide in, we realize, okay, we don't know this angle. So when we slide down, right, we wouldn't know what this angle would be. So we kind of end up in a situation where this angle is unknown, and so is this angle, right? So if we try using the sine rule now, we end up with the same 150 over two unknown angles with sine 60 over b. It's just that this changed from 120 to 60. And again, we can't solve these equations, right? So now what we need to do is use something different. Use the cosine rule, because the sine rule clearly isn't working, right? The cosine, or law of cosine. What the cosine rule states is that if you have two sides, the length of two sides, and the angle in between them, right? The length of the side opposite that is equated to these two sides and the angle in this general form, right? So let's call this B. Okay. So what the cosine rule says is that B squared is equal to sum of the squares of the other two sides. So 100 Newtons squared plus 50 squared minus 2 times 100 times 50 times cosine of this angle. So cosine 60, right? And run out of space here. You guys get the idea. Important thing to notice if you have trouble remembering the cosine rule is that this is kind of like Pythagoras' theorem, no? Yep. Sum of two squares on the other side, kind of like Pythagoras theorem. And then this is like just the other one, like 2ac. So whatever you squared here, 150, you essentially just multiply them by 2 here. And then you take cosine on the other, okay? And through practicing and working all the questions, you'll eventually just remember the cosine rule, okay? So we know the cosine rule, and if we had another triangle, let's say something like this, and this here was an angle that we knew, theta, right? This side was 2 and 3, 10, and this side here was x. The cosine rule applied to that, it's just x squared is equal to 2 squared plus 3 squared minus 2 times 2 and 3, same thing we squared here, times 2 times 3 cosine of the angle opposite the side we're trying to find, right? This x cosine. Right? So any triangle where we have 2 of these sides and an angle, then we can use cosine rule, right? So if you see this general setup, when you create your triangle of forces, this general setup, 2 sides and an angle, then you should know cosine rule should work here easily, and you shouldn't even attempt sine rule, right? When you just see this setup, well, 2 sides and they create an angle and the unknown is on this side, just start using cosine rule. Don't try sine to see whether or not it works, right? And with the sine rule, okay, when you 100, right? When you have a full pair, the angle and the side opposite it, remember the sine rule, we had these 2 sides, right? And this here was the unknown, right? This here was the unknown. But with the sine rule, we had a full pair, the 100 Newton and the angle, full pair. And we had one of the other pair, which was this angle, right? One of the other pair, here or here. So that's how we know to use sine rule. So it comes to practice deciding whether or not to use sine rule or cosine rule. So just keep practicing, and eventually you guys will just know whether or not this to start off with sine rule or cosine rule. So we know the cosine rule. Apply it to the triangle. All right. So f b squared, 4 is b squared, a squared, fc, 2 fac, right? You just call these a and c, just whatever you feel like labeling them as. I usually like labeling them as force a, force b, right? So that's b squared plus a squared plus c squared minus 2ac, right? So we know a is 50, c is 100. C, a, as given, 50. The force, 100. Use the cosine rule. Fb squared is equal to 50 squared plus 100 squared minus 2 times 50 times 100 times the cosine of 60. The cosine of 60 is it half? 2 times 50 is 100. Times 50 is 100. Right? So 100 times 100, right? This is 10,000. And cosine of 60 is 0.5. 0.5 of this here, which is 10,000, should give us 5,000. Yeah. And then this here squared. So 50 squared is 2,500, I think, and this here is 10,000. So 10,000 minus 5,000 is 5,000 plus 2,500 plus 5,000 because this is 10,000, right? Is equal to 7,500. Carry over the square, find the square root of the 7,500, and we get b is this value. Yeah. Simple enough. Any questions? No questions? So remember the cosine rule. You can always just Google cosine rule and you should find the formula if you forget it, right? And you watch a YouTube video, refresh your memory on the cosine rule. All right, so now we got the force in chain B, and now we need the angle between A and B, right? Angle between A and B. Yeah. Yeah. So now, again, let's try using either Lamy's theorem or the sine rule. So now we know the magnitude of this is 8 to 6, right? So we can go in Lamy's theorem and replace this as 8 to 6.6, right? So now we have a full pair. I can place this as 8 to 6.6, right? So now we can easily find the angles that we've been missing, right? So let's use this. And we want to find the angle opposite the 100 Newton side, right? For this here. So 8 to 6.6 divided by sine of 120 is equal to 100 newtons times sine of the angle we want to find. Now let's just call that theta. Now you do your cross multiplication, or you just do whatever magic you like to do to find theta. What I usually like to do is flip it. So put this as sine theta, or sometimes I just write it down as a flipped version from the start. And this here is 8 to 6.6 over 120 sine equal, and then just multiply by 100 newtons, right? Just multiply by 100 newtons. This here will give us an angle that's very close to 90.
Sir.
Yeah.
So you flip the right hand side, right?
Huh?
If you flip the right hand side, you won't have to flip the left hand side too?
Oh, yeah. Sorry. Yeah, my bad. Yeah. Sorry, yeah. That's a mistake. So sine 120, right? Yeah, so both signs on top now, 8 to 6.6. Thanks for catching up. So, yeah, times 100. And we work this out here. Remember, sine of 60 and sine of 120, same thing, right? So work this out here. 100 times sine of 60 or 120 will be 8 to 6.6. So let's just replace this as 120. And we already established the sine of 60 is the same as sine of 120, right? Good, right? So sine theta is equal to 100 times sine of 120 over 86.6. What you'll find is that sine of 120 is also 86.6, right? Oh, well, sine of 120 times 100 is also 86.6, right? So when we do theta is equal to sine inverse, right, of 100 times sine 120, this will just give you 1, right? So let me just put this into the calculator real quick. So 120, right? Trig, sine of 120, 86. 0.8666 times that by 100, right? This is this, and then when we just divide that by 86.6, you get something pretty close to 1, right? Good. So then we do the sine in clear 1, take a sine inverse of 1, and we should give you 90. Easy peasy, right? So the angle between A and B is 90, right? The angle between A and B is 90 degrees. Simple enough. Any questions on how we find that? No. Okay, good. So now that we know this angle is 90, if we had caught this before, right, and we had realized intuitively, because you know we're engineers and we use a lot of math, and maybe you guys did a lot of Cape maths and stuff, you could have noticed that 100 squared is equal to 50 squared plus 8 is 6.6 squared, or this here is 50 root 3, right? Great. So if you notice that this here was indeed a right angle triangle from the start, you could have just used Pythagoras Theorem and just kind of conclude intuitively that the angle between A and B is 90 degrees. But I don't expect everyone to see it this way, right? And just using the magnitudes we find and realizing that they suit Pythagoras Theorem and that the angle is 90 degrees. I don't expect everyone to be able to see this, right? So if you can't see that, just use the sine rule. Because remember, it wasn't working before, but then we found this magnitude, right? And now the sine rule or the Lamy's theorem starts working. So now we can find the angle. When we go about, we find the angle, and we know the angle is 90. Right? Good. So any questions? We'll move on. A question in the chat. Okay, so let's move on now. Answer these questions in the chat at the end of the class, because they're not exactly related to this one. Okay, good. Now moving on. We only have a half an hour left, so let me see as much as I can go. Only 2 more questions, right? Good. So number 5. 2 men carry a mass of 30 kg between them by means of 2 ropes fixed to the mass. One rope is inclined at 30 degrees to the vertical and the other at 45 degrees, of course, to the same vertical that they're talking. Determine the tension in each rope. Tension. What is this new word? Right? Tension. Okay, so let's just start describing the system. We got 2 guys, and they got some heavy box, some kind of weight, and it doesn't have handles, so they decide to tie some rope onto it and carry it like that. So 2 guys, and they're carrying this box, and of course gravity acts downward. So we start to see a force diagram coming up about here, right? And of course, the angle here to the vertical are 30 and 45 degrees, because one guy might be taller and one guy might be shorter, right? So they create different angles with the rope with respect to the vertical. So let's translate this into a diagram. Okay. So the mass, right? How much does the mass weigh? 30 kgs. The mass weighs 30 kgs. 30 kgs, right? And then we times that by gravity. Remember, weight. 1 kg exerts 9.81 newtons of force downwards as a result of gravity. So 30 kgs times 9.81. The force exerted by 30 kg should be about 294.3, right? So we just multiply by this gravity coefficient, 30 by 9.81. And we get this downward force. These 2 other forces here are one guy pulling this way and one guy pulling this way, and as a result, lifting up this box and carrying it. And as stated, these angles are 30 and 45 degrees. Okay, simple enough. Good. So now let's create a triangle from this, right? Or you can use Lamy's theorem. Yeah, just 30 plus 45 is 75, and you use Lamy's theorem and you feel your way out. But let's use the Sine Rule. Give you guys some practice. Create triangle. Okay. So let's slide this up, and we know the angle between here is going to be 45. Great. We slide this up, slide this across. So what essentially this becomes is kind of something like this. So things like this, one like this, one like this, and this vertical here. We can somehow deduce that this 30 here is the same as this 30 here, right? So here and here, and the same thing. That's the angle we have here, right? So 30, 45. 30 plus 45. 30 plus 45. 45. 30 plus 45 equal to 75. Okay, so therefore this actual angle here, the angles, the sum of angles within a triangle, 180 minus 75, what is this equal to? Well, calculations 105. Great, so you can find it here. Or you can just draw a line down, create two perpendicular triangles, call this 90, and then do the subtraction quick. Find this here, call this 90, do some addition and subtraction quick, and find this, and then add them up, and you'll get the same 105, right? However you want to find this angle here. Yeah. Okay. Yeah. Okay. Or you can do something like this, move this down here, right? This here is 75, this here is 180, yeah? So therefore this angle here, which is the same as this, right, is the 180 minus 75, right? So you can find this angle here. Agreed? And we'll find this angle as 105. Good. So now moving on. We found the angle 105, and this side opposite it, 294.3, right? We have up here, we have an angle and an unknown, an angle and an unknown. So there's a similar situation, right? There's the same situation as number 2 that we worked before, okay? And the second part of number 4 that we worked before. So we know that sine rule is the rule you want to use because we have this pair here, right? Good. So we create sine of 105 over the 294.3 is equal to the FA over the sine 45, FA and FB. FA and FB, 30 and 45, and we set up our sine rule. Good, so we know FA we carry over. So FA is sine 45 times whatever this evaluates to. So what I did, I just plugged this into my calculator and it output this value, right? Just kind of write that down and then multiply that by sine 45. Get this here. And then carry over again for sine 30 to find FB, this. So essentially what we're doing is creating two equations, 30 294.3, which is what this 30 times 9.81 is, over sine 105 is equal to FA, or just A, whatever you want to label it as, sine of 45. And of course, just carry this over, multiply, or you do your cross multiply method. However you want to solve this equation. I usually just like to take it from here, multiply this thing in the jig by sine 45, right? 45, and then this answer is FA. So FA, sine 45 times whatever this evaluates to in newtons, right? Great. Then we do the same. We just replace this with FB, and the angle here is now 45, it's 30. So this here is sine 30. Right? So sine 30 times 204.68178. And they should output 52, right? And these are the answers in the book. Good. So I know I use a lot of decimal places, but you guys can just keep them whole and move over and then just input all of this into the calculator, or you can do it piece by piece, right? Okay, so however you want to do it, however, whatever works well for you, right? Okay. Any questions on this stuff? Something that might have just went over your head? All right, it's simple, right? And it's the same as the ones we might have worked before. All right. So of course, I'll send this to you guys and you can practice the questions on your own. And look at these solutions for a little guidance. And Miss also has her solutions. So you can look at that for some guidance also. And to see where you went wrong if you didn't get the right answer, right? All right, so number 6. And number 7 is easy. So this is the last question I'm gonna work. And number 7 is easy because number 7 is when you read, it's essentially just a right angle triangle, right? So downward and to the right. So it's just a right angle, and you'll do. I trust in you guys to be able to figure this one out, right? So let's do number 6 and then go home. Well, not go home, log off because it's Zoom classes now. Okay, good. So number 6. A chain 3 meters long has its end fixed a horizontal girder at points 2m apart. A mass of 1 megagram, right? Megagram is suspended from the chain at a point 1 meters from one end, right? Determine the tensions in the 2 parts of the chain. Hold on, tensions again. So I highlighted it, but I forgot to explain it last class. So tension. So as we know, a force, right, is either a push or a pull. Yeah, push or a pull. What tension is? Tension is a pulling force for things like cables, right? Cables, chains, rope, string. If the load is light enough, string, chain, and rope, right? So it's essentially the pulling force of these string-like materials, these cables, these chains, these ropes and stuff. So that's what tension is. It's the pulling force. So when you see tension for this class, just think force and then go about your calculations, all right? All right, good. So that's what tension is. It's the pulling force in these cable-like things, these cables, these chains, these ropes. It's pulling force. That's what tension is, right? So determine the tension in the 2 parts of the chain. So essentially, what force is pulling, right? Good. So let's create a diagram. A horizontal girder. So civil people know it is that this is girder is some metal thing that we use to build buildings, right? And we attach a chain at points 2 meters apart. A 3 meter long chain at points 2 meters apart. So 2 meters, 1.2 meters apart. We attach a 3 meter chain, right? Okay. And then we hang a mass of 1 megagram, suspended from the chain at a point 1 meter from one end. So from one end, 1 meter from that one end, 1 meter, right? 1 meter from that one end, we hang a mass. So therefore, this other end, the length, right, should be 2 meters, right? So keep that in mind. And we actually determine the tensions in 2 parts of the chain. So let's look at this diagram. What forces do we have? Well, we have the mass. So 1 megagram is 1,000 kgs, right? Convert 1 megabyte. You guys that are technology oriented, 1 megabyte, 1,000 kilobytes. So 1 megagram is 1,000 kilograms, right? So just remember that for when these megas pop up. So 1 megagram is 1,000 kilograms. So therefore, the weight of this mass is 1,000 kgs times 9.81, which goes into 9,810 newtons, or 9.8 kilo newtons. All right. Good. Now another thing. So we know one force. We don't know this force. We don't know this force. And another thing we're gonna notice really quickly is that, hey, we don't have any angles. We don't know this angle. We don't know this. We don't know this. We don't know any angles. But what we do know are the lengths of these. So now, even though we don't have the magnitude of the forces or the angles, we do know the lengths, right? So we can use the lengths to find the angles. So let's extract this triangle here so that we can find some angles, right? So here's 2 meters, here's 2, and here's 1. So 2, 2, 1, and label the angles accordingly. So let's find these angles and see if they can help us. How we can find these angles, right? Now we can't use sine rule because we don't have any full pairs. So sine rule might be confusing. And what we can use though is cosine rule because we're missing an angle. So we have 2 sides, right? We don't have the angle, but we do have the other side, right? So we can use that with the cosine rule and kind of reverse it in a way and find the angle. So let's apply the cosine rule to find the angles in here. Very good. So the law of cosines, 2 squared, 2 plus this 2 here. I'm trying to find this theta is equal to the other 2 sides squared, 2, 2, 2 and 1, 2 squared plus 1 squared minus 2. This is just general 2 from things like 2 minus 2 AC. And then 2, 1, which is this 2 again. And this 1, which is this one here again. Cosine the angle we want to find, which is this theta. Yep. Okay. Put that all into the equation. And we solve for theta, which is what we don't know. Yeah? So 2 squared. 2 squared is 4 plus 1 squared is 1. 4 plus 1 is 5. Yeah? 2 by 2 is 4 times 1 is 4. So 4 cosine theta. 2 squared is 4, right? Okay, good. Carry over. Sine theta. Yeah. So we carry over. So this becomes 4 minus 5 minus 4 over cosine theta. So this here is just minus 1. And then we carry over the minus 4, right? Minus 4 is equal to cosine of theta. So minus 1 over 4, this is essentially just quarter. You can think of it like this, right? This is just essentially a quarter. So theta, we can say, is equal to the cosine inverse, right, of quarter, which is this thing here, right? And that is this magical number here. So plug it into a calculator, and the calculator outputs 75.5 degrees for theta. Good.
Sir, can you scroll to the diagram? I would like to see something.
Yeah. So this theta here is equal to 75.5 degrees, as we just find using the cosine rule. And now we know from, I guess, primary school and secondary school that triangles with two equal sides, the two of the angles are equal, the angles opposite those sides, and then there's one unusual one, right? So we know that this here is also 75.5. Yeah? This here is 180 minus these two angles, yeah? So to find this other angle, here, we do 180 minus the 275.5, and you find this other angle is 28.95 or 28.96. Yep. 28.9. Yeah, 955 rounded 96. So again, remember this triangle: 2 meters, 2 meters, 1 meters, 2, 2, 1. We found this side using cosine rule. We know equal sides, equal angles, 75, the same as this one. Then you subtract that from 180, right? 180 minus 275.5. Good. 28. Shouldn't be hard. Good. Now we're moving on. So we get some angles. Maybe now we can solve some stuff. Yeah. All right, good. So we found this one here, 75, right? 75. This here is also 75.5, of course, but let's just keep it simple. And this here is 29, yeah, or 29, yeah, 29. So we have this angle here, yeah. Now what we can do is, this here is a horizontal girder, right? So this is a horizontal reference. This here is a vertical. So if we draw a horizontal reference here, we end up with this here, horizontal line. So this here is also theta. Yep. This here is also, yeah. And then this is a horizontal and this is a vertical, right? One mass, so mass, and mass is act vertically down. So this here essentially just 90. And you can find these angles here, 75 plus 90, and you find this angle here and this angle here, and you use Lamy's theorem. Or you just create a triangle real quick. Have this force down, move this force over, right? Move this here, and move this here, and then work some magic and find some angles, right? And so if we have this entire angle here, which we calculate is 90 plus theta, if you wanted to move this one here down here, down here, this would be, I'm just getting my calculator. This would be 180 minus 75 minus 90, right? Which would give us about 14.5 if you do 17.5, right? Which would give us this angle. And of course, this you can kind of just extend this or do it as here, right? And imagine another vertical here, right? So this here is your angle X or whatever, and this here is your angle X, to realize that this here is that angle. Or you can move this up here, right? And this here is a 90, right? Minus 75.5 is equal to that. So however you want to find the angles in your triangle, or if you just want to go ahead and use Lamy's theorem and find this 14.5, right? And similarly for the other side, right? You slide up, and you'll have here, this alpha here, right? You slide up, so 90, right, minus 29 should give you 61. Yeah, and then you put the angle in here. So you find the angles, whatever, and then you add up 180 to find this other angle, or of course just do right angles here, and work these angles in here and then add them up and get 104. So you can just add these two up, right? 180 minus 61 and 14 minus 14.5, and you should get 104, give or take, depending on how many decimal places you use, right? Or you can just do some stuff here, theta, and realize that this is 28 and this is 75, and then add them up and get 104, right? So whatever you want to do, this angle here is 104. Okay. Now we used the law of cosines already. Now we're using law of sines. Make some space. Okay. So we know this side is 9,810 and this side is 104. So this here is one complete side, right? One angle on one side, and one angle and one unknown, right? And one angle and one unknown. So we can use the sine rule here. Or if you didn't go this far and you just went here and started using Lamy's theorem. Yeah. So we create our triangle of forces. We know this 9,810 times, and the angle opposite it is 104. That's equal to T2 over sine 14.5. Two here, sine 14.5 here, and T1 sine 61.04. That in here, create our sine equations, and of course solve for T2 and solve T1. So let's just solve T2 real quick. 9,810 newtons over sine 104.46 equal to T2 over sine 14.5, right? Do your cross multiplication or just carry over this here, sine 14.5, this, and you equate this. I equate this out first. What is that? And then I multiplied it by sine 14.5. Or you can just plug this entire thing into a calculator and output the value for T2. And what you'll find is T2 will be this in newtons. Or if you had replaced this with 9.81 kilonewtons, you could put it there. Or you could just take this number, right? Floating points, 1, 2, 3, 2.536. So this is 3, the number before 6, which is higher than 5, so this becomes 4, right? So we round, and we get 2.54. Yep. Any questions on this? I know this question is a lot, and it's a lot of stuff going on, but as long as you follow the procedure, right? You use the measurements to find the angles, then you use the angles to find the missing forces. And don't get confused when you see tension, because tension is just the pulling force in things like cables, chains, and ropes. Okay, pretty simple. Any questions? So first you find the angles using the triangle. So you use cosine rule. And then once you find the angles, you create a triangle, or you use them to deduce the other angles. And then you use law of sines or Lamy's theorem, and you find the missing forces. Yep. Any questions? All right, so
Questions.
yeah, go. Yeah, question. I'm not hearing your question. All right, well, that's essentially the end of the class. Number 7, you guys can work it on your own if you paid attention. So what it's essentially saying is a mass of 30 kg is suspended by a cord attached to a ceiling. It's being pulled to one side by a horizontal cord, and this mass 30 kg, gravity acts vertically downward, so creating right angles here, and this cord here being pulled horizontally. So this here still makes an angle of 30 degrees to the vertical, right? And you create your force diagram. Force is a right angle triangle, so you move some stuff around, slide this down, bring this across, create your diagram, deduce your angles, right? And just use your trig ratios and find the stuff. Yeah. All right, so that's it. End of class. Hope you guys learned something. If you didn't learn anything, go over the material in the handout. I already sent you guys this PDF here, so you can go over that. If while you're going through it, you find any mistakes somewhere, let me know so I can tell the other students to look out for that mistake, right? All right, and remember to practice your questions and keep up to date with Mr. Sil for tests and assignments and when classes are due and what material you're supposed to know. Thanks. Enjoy the rest of your day.